Hey guys, welcome back to AlgoYogi. We are doing array and hashing series, and our next problem in the list is largest three same digit number in a string. So let's go to LeetCode. There we go. You are given a string num representing a large integer. An integer is good if it meets the following conditions. It is a substring of num. Num is given to us. It's a large integer that's given to us as a string. Now this good integer that we are looking for, its conditions are: it is a substring of the num that's given to us with length 3, and it consists of only one unique digit. So it's going to be either 111, 222, 333 till 999, right? So that's what it's going to be. Now we need to return the maximum good integer as a string or an empty string if there is no such integer exist, right? So it might happen that like this substring, so either 111, 222, these three number unique three same numbers either don't exist in our num, or if they do, then we need to return the maximum of all of those. And these are the note. A substring is a contiguous sequence of characters with a string. We know that there may be leading zeros in num, or a good string, All right, so that makes sense. So let's solve it. So we are given num. This num is a string that consists all the nums from 0 to 9. Now we need to look for a good string in this, and we have to return the largest good string. And the property of good string is, good string property are three same digits. Okay, that's first property. Second is we have to return it only consists of, I think this is the same property, like I've already said, three same digits, so that covers even all of it, three same digit. And we have to return the largest good number. Yes, good integer. So good integer, not good string, sorry, good integer. All right, so how do we actually go inside my num? How do we iterate this num and check for the largest good string? First, let's just check if there are three numbers that are equal, and then we can update basically the largest one, right? So I will declare, let's say, I will say largest here. Initially, I'll just have an empty string, because we have to return this number as a string. Then inside my num, I will basically maybe do a sliding window. Sliding window seems to be the best approach, right? So what I'll do is I will look at the first window. This is the first window that I see. Are all the numbers same here? No. So this is not even a this does not qualify as a good integer even. Forget about being the largest. Then let's go to the next one. Now I see 777. Yes, this is. So 7 equals to 7 equals to 7. I can check this. I can iterate until like the second last, or right here, until this index, and then check this number, the number next to it, and the number next to it. All right. So what I'll do is I will update my largest with 777. All right, so I will update this with 7, 7, and 7. Then I will go next. Well, now this does not qualify. Maybe a better way would be this. This does not qualify. This does not qualify. This does not qualify. This qualifies, but it's not greater than 777, so that is why we'll skip it. We'll skip all threes. This also qualifies. This does not qualify. This does not qualify. That's not even three numbers. So I think that is that's the simplest approach that we can follow. Basically, this sliding window of three integers at a time. We can start our iteration at 0 and go up to the length -2. that will take us like to the third last index, and then we can basically check for each index the number next to it and the number next to it, and if that number they are all equal, then we can update our largest one. So I think this seems to be really easy solution, and it's going to have a time complexity of big of n, because at max we are going over the entire length of our num. N is the length of num. Space complexity, not really we are using anything, so space complexity will be big of 1. That is all. It was one of the simplest questions we have solved so far. So let's write down the answer. Switch the view. So as I said, initially we can say largest number. We can say largest num. That would be just empty string. Then we can go over for I in range, and length of this num -2, not -1, -2. And if this num, this num that I'm seeing, so this num, if num at I is equals to num at I plus 1, and then is also equals to num I plus 2. That's right. So if this is the case, then we can actually now try to create this new num that will be str into num I multiplied by 3. So that's the number, or you can join all of them by converting into a string, but this is easier, right? So that's the new number, and I'm gonna update my answer. So that will be a maximum of whatever I have already, or this new num that I have just found, this continuous block of 3 same digits. All right. Or there is one more thing that we can do to optimize it. If let's say if this largest is actually now equals to let's say 999, then we can just return this largest number, because you don't want to keep going again and again. If you found this is by far the largest number that you are going to see, right? So why not just skip out all the other iterations, because you found the largest number, so it's not you're not going to update it anymore. That is why you can just simply return. Otherwise you can return here whatever the largest number that you have like collected here so far. And I think that would be it. Let's zoom out and test it on the example test cases. Yes, this works perfect. Time complexity, as I said, it's going to be big of n, because at max you are going through the entire length of num. That is the best time complexity you're gonna have so far anyway. And space complexity is going to be big of are we using any space? No. So 1, or maybe the length of largest now, which is 3. So 3 is still constant 1. Now let's go back to AlgoYogi, mark this problem solved, and see you guys later in the next problem. Bye bye.